let's talk about Camera-Lidar calibration. So in front of me, you can see my unplugged Velodyne VOP16 and my hi-fi sensor. So both of these sensors are in a rigid formation, and I'll be moving the board around during this demonstration. However, know that for Camera-Lidar, you can also have a board set and be moving the module instead. So similar to cameras only, we can move either the rig or the sensor or the targets, but we shouldn't move both. Now, with that in mind, there are a couple things that need to be in your LiDAR dataset in order for us to process its. One would be the position, so the XYZ coordinates of every point coming off of your LiDAR. The second is the intensity or reflectivity values off of the sensor. We don't need both, we just need one. Now, with these intensity and reflectivity values, we actually don't care about the beam pattern of the LiDAR itself. So if we have a Velodyne POP16, it's no different from a 64, which is no different from a Livox sweep. We can process all of them, we just need those intensity values. And what allows us to do that is this fiducial here. So we have the fiducial is going to be made up of our marker board in the sensor. This is going to act as our camera registration point. So the camera is looking for these features in the middle. The LiDAR will be looking for this retroreflective band of tape on the outside, which is in a circle formation, specifically so we can detect it in very busy scenes. There are very few things that have a perfect circle in nature, and we find that this is best to refine the feature. Now, important to note that the width of your tape doesn't matter necessarily. It's really just the radius from the center of the board. We're looking for that radius specifically in order to identify this. So if you have two different circle boards, it's important to have different radii between them. And in fact, MetriCal will confuse boards that are within 10 centimeters of radii between one another. So with all that being said, we're ready to capture. Capture is very similar to camera only in that we're going to be looking for angles with periods of stillness and motion. So one might be tempted to keep the board facing the camera the entire time. This is actually detrimental to the calibration because, again, as we said in the single camera video, we're going to be encountering some serious projective compensation in that case and confusing our intrinsics and extrinsics for the system. So what we really want to do is fit those angles. Our detectors are very good. Don't worry about detections getting lost unless your detector is very far out, in which case the resolution of the image is just going to drop. Not our fault. Make sure to get these angles, rotate the board in all three roll, pitch, and yaw axes. And then, dip down. Go back and forth with this. Go far and close. And just do this until you get the full frame of view of the camera.